Hey students, welcome back. Now here, as I told you, we're going to talk about what is the pressure exerted by a gas molecule. For example, around you there is air, right? Now air is a mixture of oxygen, nitrogen and other gases. Oxygen 21%, nitrogen 78% and remaining 1% is carbon dioxide, water, vapor. So what must be the pressure exerted by air on the walls of the container? What we call it as atmospheric air pressure. So if there is atmospheric air pressure, that means there is gas pressure also. So before we start with the expression of gas pressure, so what is the pressure exerted by a gas, we first need to understand certain assumptions. We call them as postulates. We have a gas. First of all, a gas is consisting of large number of tiny and identical particles which are known as molecules. We have already spoken about this. These molecules are perfectly elastic and rigid spheres. Now in the chapter of elasticity we have said that the body which can be deformed the least is most elastic. Right? That means the body which cannot be deformed at all. The body which cannot be deformed at all is most elastic, and that is a rigid body. So either you call it as perfectly elastic or rigid, meaning is the same. So these gas molecules basically are those which cannot be deformed on application of any amount of force. So we call them as rigid spheres. Next, the volume of all the gas molecules is very small compared to the volume of the container. If I think about a molecule, its radius is approximately 10 raised to minus 10 meter, approximately. So volume will be 4 by 3 pi r cube because they are spheres, right? It is of the order of 10 raised to minus 30. So this is one. Suppose I am taking a container. Let us assume that this container is cubic in nature. Okay, cubic in nature. Okay, if I am talking about this molecule, this molecule, this molecule, this molecule, this molecule, this molecule, this molecule. Let us assume I have taken 1 kilomole of a gas. That means it has Avogadro's number. That means it has 6.03 into 10 raised to 26 molecules. एक molecule का volume है 4 by 3 pi r cube. So n0 molecules का volume है n0 into v. That means into n0, right? अब इसका size 10 raised to minus 30 है, minus 30 approximately. तो भले ना ये 10 raised to 26 है, लेकिन फिर भी 10 raised to minus 4 power है. Moral of the story: if I take volume of this molecule plus volume of this molecule plus volume of this molecule plus volume of this molecule, if I combine all the volumes, then also volume of all the gas molecules is very, very, very small compared to the volume of the container. So, point number 1, a gas consists of large number of tiny identical particles which are known as molecules. Next, point number 2, these molecules are identical in all respects. Okay, they are perfectly rigid spheres. Next, volume of all the gas molecules together is also very small compared to the volume of the container. Next, every molecule has certain region of space around it, and the certain region of space is known as sphere of influence. Right? If any other molecule comes in this range, then only it is attracted or repelled. Then only it is attracted or repelled. This is something like this. Suppose this is Earth. Earth has a gravitational field around it. Moon comes in that gravitational field. That's why Moon revolves around the Earth. Am I right? अर्थ का एक मून है, लेकिन वो अर्थ के आजू बाजू में ही घूमता है, जुपिटर के आजू बाजू में नहीं घूमता है. जुपिटर का अपना मून है, टाइटन एंड ऑल दैट. फॉर एग्जांपल, they will not revolve around the Earth. That means every planet has a certain sphere of influence around it, which is called gravitational field. Likewise, every gas molecule has a certain region, which is called sphere of influence. Right? First of all, these gas molecules are far from each other because solids में the molecules and atoms are compactly placed. Liquids में they are radius free. Gas में they are most free. That means these gas molecules are far from each other. No doubt they are moving. They try to come close. Right? But again they go far. Now, because they are extremely small, who? The molecules. Therefore, the spheres of influence are also very small, and therefore we say that these gas molecules neither attract nor repel each other. And because they don't attract, don't repel each other, that means their overall potential energy remains constant. Their overall potential energy remains constant because potential energy is decided by either the configuration or the location. Either the configuration or the location. Now, because the force of attraction or repulsion are negligibly small, potential energy remains constant. ये बेटा सारे के सारे assumptions आपको याद रखने हैं. ऑर्डर अलग अलग होगा चलेगा, जरूरी नहीं कि फर्स्ट के बाद सेकंड याद रखना चाहिए, सेकंड के बाद थर्ड याद रखना चाहिए. नो, it is okay. In whichever order you want to remember. But remember. Next, these gas molecules are in a constant state of random motion. That means they move in a haphazard way. They move in a zigzag way. For example, molecule first location से second पे गया, second से third पे गया, third से fourth पे गया, first से second पे गया, किसी को टकराया, it collided with someone, changed its path, third पे आके और किसी से collide हुआ, right? So when it goes from one location to the other location, that path is a straight line. That path is a straight line. It's called free path. But if you see the overall path, it is not a continuous straight line. It is zigzag. 1, 2, 3, 4. Haphazard way. Now this zigzag motion is similar to the motion observed by a scientist, Mr. Robert Brown. Mr. Robert Brown. He was a botanist. He observed the movement of the pollen grains under microscope. He observed the movement of the pollen grains under microscope. Who? Robert Brown. Right? And he found this motion to be like this, zigzag. So, as a respect, this motion is also known as Brownian motion. It may help you in MCQ. It may help you in multiple choice. Okay, now, length of a free path may not be the same. When it goes from 1 to 2, right? Now when it goes from 2 to 3, this length and this length need not be the same. This length and this length does not be. So we talk about average free path. We talk about average free path, which is also known as mean free path. Which is also known as mean free path. Right now we will do only the basic definition. It is denoted as lambda and it is S upon N. Lambda का मतलब mean free path, S का मतलब total distance traveled, total distance. Okay, what do I mean by that? 1 to 2, 2 to 3, 3 to 4, 4 to 5, 5 to 6. All these distances have to be added upon number of observations. Upon number of observations. So lambda is S upon N is called mean free path. Henceforth we will call this MFP, mean free path, average free path. We are going to talk very much in detail about this later. Right now we will do the basic definition. Thereafter we see that these gas molecules, they collide with each other. This is molecule 1, this is molecule 2. So molecule 1 collides with molecule 2, goes somewhere else with molecule 3. Then it collides with the walls of the container also. Wall, etc. That means these gas molecules, when they move, they collide with each other and they collide with the walls of the container also. Next point. These collisions are perfectly elastic. Remember, we have done this in work, power and energy. If the collisions are perfectly elastic, then two things happen. I would like to change the point. I would like to call this as 8 point, I would like to call this as 9 point, I would like to call this as 10 point. If the collisions are perfectly elastic, then the momentum is conserved and then the kinetic energy also is conserved. What do I mean by momentum is conserved? Momentum before collision is momentum after collision. That is m1 into u1 plus m2 into u2 is m1 into v1 plus m2 into v2. Momentum is conserved. What do I mean by kinetic energy is conserved? Half m1 u1 square plus half m2 u2 square is half m1 v1 square plus half m2 v2 square. That means there is no loss of kinetic energy in the form of heat, sound, etc. Please remember, these molecules are extremely small. See, if you are playing a game of pool or carom board or something like that, when the striker strikes the coin, a sound is produced. Because they are really huge things. Now, these gas molecules are so extremely small that even if some energy is lost in the form of sound or heat, we don't realize. For example, air particles must be colliding with each other. Oxygen cylinder, in that oxygen molecules must be colliding with each other. Do we get to hear sound? No, because they are extremely small, so we don't understand this. Next, the average kinetic energy of the molecule. The way we spoke about potential energy, we must speak about kinetic energy also. The average kinetic energy of the molecule is directly proportional to temperature, absolute temperature. We are going to prove this officially, right? Proof later, mathematical proof later of this point. Okay, but we can understand this logically at least. If I increase the temperature in this classroom, right, then the gas molecules will start moving more vigorously. The gas molecules were already moving, right? That is, they already had kinetic energy. But because they get support of thermal energy, they will move more vigorously. They will perform more number of collisions per second. They will collide with more number of times with the neighbors and with the walls. So we say that the average kinetic energy of the molecule is dependent directly on the absolute temperature. That means if the absolute temperature is doubled, kinetic energy is doubled. If the absolute temperature is made 5 times, kinetic energy is made 5 times. Suppose the room temperature right now is 27 degrees Celsius, which is 300 Kelvin, and the kinetic energy is X. If I make this temperature 1500 Kelvin, not Celsius, 300 Kelvin to 1500 Kelvin, that means I am making the temperature 5 times. Then the average kinetic energy of the molecule is also found to be 5 times. The next assumption, all these assumptions we are going to make use of them beautifully when we start deriving the expression for pressure exerted by the gas. Right? The final point is that the time of impact, that means the time for which one molecule is in contact with the other molecule, or one molecule is in contact with the wall, is very small compared to the time taken by the molecule to travel from one place to the other place. What do I mean by that? This molecule is traveling from here to here, and suppose it takes 3 milliseconds. Then the time for which this molecule collides with this molecule will be few nanoseconds, picoseconds. That means this molecule is in contact with this molecule for few nano or picoseconds. But the time taken for this molecule to go from here to here is a few milliseconds. Right? It is something like this. The time, suppose I am playing the game of cricket. Then the time for which the ball is in contact with the bat is very small compared to the time taken by the ball to travel from the bowler to the batsman. Think on this. Think on this. Time taken by the ball to remain in contact with the bat is very small compared to the time taken by the ball to travel from the bowler to the batsman. So likewise, the time for which one molecule is in contact with the other or with the wall is very small compared to the time taken by the molecule to travel from one location to the other location. So, all these assumptions, please remember them extremely well, because they are going to help us in understanding the mathematical expression like pressure exerted by the gas molecule. What is it? Right? So our next article, that is lecture number 1C, is going to be very important article where we are going to talk about pressure exerted by the gas molecule. But before that, one very small thing, right? Sorry, I am continuing with B, where we are going to talk about 3 very simple things. One is mean velocity, means average velocity. Other is mean square velocity, and other is root mean square velocity. So, 1B continues where I am going to talk about 3 very simple definitions, because we are going to need them in the main derivation, that is pressure exerted by the gas molecule on the wall of the container. So before that, 3 very simple definitions. Now here, we need to use our knowledge of vectors a little bit, because velocity is a vector. So now, concept of mean velocity. Mean means average velocity. Mind you, it is denoted as C bar. Bar means mean. Then comes, let me call this as 1. Second is mean square velocity. Mean square velocity. Why do we need that? I will explain that also. Mean square velocity. That is C, mean square velocity. And the third concept is very important. it is going to be useful in many different chapters. Useful in many different chapters. The concept of root mean square. The concept of root mean square. Root mean square velocity. Root mean square. That is C bar mean square root. Or as it is also written as CRMS. Root mean square velocity. Okay? Now listen to this very, very carefully. If I am giving you a container, let us assume this is a cubic container. Okay? This is a cubical container. Whose length is L, whose breadth is L, and whose height also is L. Okay? I would like to call this as origin. I would like to call this as x-axis. I would like to call this as y-axis. And I would like to call this as z-axis. If the molecule travels along x-axis, then let me call x component of the velocity as u. If the molecule is moving along y-axis, let me call y component as v. And if the molecule is moving along z-axis, let me call z component of velocity as w. Right? X component is u, y component is v, z component is w. But if the molecule is moving in two dimensions, that means it will have combination of u and v, ya to v and w, ya to u and w. That means it will have two components. But what if the molecule is moving in space? If the molecule is moving in space, three dimensions, that means it will have x component also, y component also, and z component also. And therefore, the overall answer should be none of them. It should be combination of all. Overall velocity is called P bar, and it is u bar and v bar and w bar. Mind you, this is vector sum. This is not algebraic sum. No. Algebra में 2 plus 3 is 5. Algebra में. But vectors में 2 और 3 का सब क्या होता है बेटा याद करो. It always lies between difference and sum. If I am having vector of size 2 and another vector of size 3, my answer lies between 1 and 5. It cannot be less than 1. It cannot be more than 5. और याद करो बेटा मैग्नीट्यूड ऑफ वेक्टर कैसे ढूंढते थे? स्क्वायर रूट ऑफ sum of squares of x component, y component and z component. So C is the velocity of the molecule and it is square root of sum of squares of x component, y component and z component. ये रफ बैकग्राउंड है, मतलब एक ही मॉलिक्यूल के बारे में बात कर रहे हैं, एक ही मॉलिक्यूल के बारे में बात कर रहे हैं. Now suppose C1, C2, C3 right up to Cn are velocities of n molecules, then what will be mean velocity beta? It will be C1 plus C2 plus dot 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 plus Cn upon n. So this is the first definition. Mean velocity. Right? Now very important. उसका यूनिट क्या होना चाहिए? मीटर पर सेकेंड. Now something very important. Velocity is a vector, ना? Velocity is a vector. और वेक्टर नेगेटिव भी हो सकता है. For example, why do we need root mean square velocity? ये उसका आंसर है. अब एकदम ध्यान से सुनो बेटा. मेरे पास 4 मॉलिक्यूल्स, ओके? मेरे पास 4 मॉलिक्यूल्स हैं. मॉलिक्यूल्स 1 2 3 4 और उनके वेलोसिटीज है 1 मीटर पर सेकेंड, 2 मीटर पर सेकेंड, -1 मीटर पर सेकेंड, -2 मीटर पर सेकेंड, क्योंकि वेलोसिटी नेगेटिव हो सकता है. अभी जब मैं इसका एवरेज निकालने जाऊंगा, एवरेज क्या आया बेटा? एवरेज 0 आया, 0। यू नो व्हाट डज दिस मीन? इसका मतलब ये होता है कि द एवरेज वेलोसिटी विद द गैस मॉलिक्यूल्स मूव इज 0। अब ये कॉन्ट्रडिक्शन हो गया, अब ये कॉन्ट्रडिक्शन हो गया, बिकॉज़ एक बार दोनों को मूव, दूसरी बात को 0। आगे सुनो, काइनेटिक एनर्जी इज डायरेक्टली प्रोपोर्शनल टू एब्सोल्यूट टेम्परेचर। बोला था आपने एजम्पशन, राइट? इफ टेम्परेचर इज 0 केल्विन, then only kinetic energy can be 0, then only velocity can be 0। लेकिन ये अभी तक यूनिवर्स में मिला ही नहीं है, एब्सोल्यूट 0 मिला ही नहीं है। तो अगर टेम्परेचर 0 नहीं है तो काइनेटिक एनर्जी 0 नहीं है, काइनेटिक एनर्जी 0 नहीं है तो वेलोसिटी 0 नहीं है, वेलोसिटी 0 नहीं है तो एवरेज 0 नहीं हो सकता है। मतलब कुछ तो गड़बड़ है। नाउ कम समथिंग ब्यूटीफुल, समथिंग वेरी ब्यूटीफुल। यहां पे एल्जीब्रा करेक्ट है, एल्जीब्रा इज करेक्ट, है ना? 1 + 2 + -1 + -2 अपॉन 4 इज 0। एल्जीब्रा इज करेक्ट, बट फिजिक्स इसके साथ एग्री नहीं कर रहा है। फिजिक्स सेज दैट दिस इज करेक्ट, ये हो ही नहीं सकता है, बराबर? देन व्हाट टू डू? माइंड यू, whenever you are stuck up like this is called traffic jam condition. How to come out of this? सिंपल बेटा, इसका स्क्वायर करो, इसका स्क्वायर करो, मतलब स्क्वायर करके फिर एवरेज करो। तो 1 का स्क्वायर 1, 2 का स्क्वायर 2, 4, -1 का स्क्वायर 1, -2 का स्क्वायर 4 अगेन। तो ये एवरेज 0 नहीं होगा, ये एवरेज 0 नहीं होगा, लेकिन इसका यूनिट हो जाएगा